Hello Legacy students, this is Miss Marsh speaking. What we're going to look at today is section 2.4, which is solving equations with variables on both sides. What you're going to want to make sure that you have is, you're going to want to make sure you have your notebook out, you're going to want to make sure you have a writing utensil, so a pencil or pen, and also you're probably going to want a calculator. So what is this video going to actually focus on? So we're going to look at how to solve variables on both sides and identify equations that have infinitely many and no solutions. So we're going to look at quite a few things today. What you're going to want to do, you're going to make sure you get these steps down. So you're going to want to write this down. So, first steps that we're going to use. If we see anything with distributive property, we're going to make sure that we actually use the distributive property. So that's going to remove any grouping symbols that we have, so any parentheses really. Now we're going to clean up some rational numbers by multiplying by the least common denominator. We're not going to look at a whole lot of those today. We're going to mostly focus on integers, no rational numbers. Then we need to combine like terms on each side of the equation. Then we're going to get the variable terms on one side, so the ones with the x's. And then we're going to get the constants, which is just the numbers, on the other side. Then we're going to solve for the variable. So we're going to do addition and subtraction first, and then only can we do multiplication and division. So what you're going to want to do is you're going to want to pause the video to make sure you get all these steps down before you continue on. So here's the first problem. So go ahead and make sure this one also gets down into your notes. So they want to know what is the solution for 5x plus 2 equals 2x plus 14. So I'm going to write down my problem just like you should. And I'm going to start solving. So I am first going to take care of these, of my numbers, just the lone numbers. I'm going to leave the x's for a little bit. So I'm going to subtract 2 from both sides. You could have subtracted 14, but I like to subtract 2. My 5x is just going to come straight down. Now, plus 2 minus 2, it's going to cancel out. It's going to give me 0. On this side, I still got 2x. And then 14 minus 2 is going to give me a positive 12. So now I need to get my x's together. So I'm going to subtract 2x because I want to get these x's away from this 12. They can't play nice together. They need to be away from one another. So on this side, 5x's minus 2x's is going to give me 3x. And on this side, I'm going to get those cancel out. It's going to give me 0. And I'm going to be left with 12. Now, addition and subtraction, I've already done my addition and subtraction up here. So I'm going to divide by 3. And I get x equals 4. Because my 3's are going to cancel. 12 divided by 3 is 4. Now let's look at this one. Gotta write it, 7k plus 2 equals 4k minus 10. You're also going to want to make sure you get this one down in your notes too. So I'm going to add 10 to both sides. I'm going to get 7k plus 12 equals 4k. Now, I need to get my k's to their own side, so I'm going to get rid of this 7k. Can cancel out and get 12 equals negative 3k, because 4k's minus 7k's gives me negative 3k's. Now, I need to get k alone. Divide by negative 3, because that's what multiplication right now is going in there. So I'm going to get, once those guys cancel out, on the right hand side here, I'm going to get k. And here, 12 divided by negative 3. Give me a negative 4. Now, one with grouping symbols. This one's just a little harder. So I'm going to make sure I do my distributive property. So I need to do my rainbows. So I'm going to go 2 times 5, 10x. 2 times -1, -2. Got to do another distributive property, it looks like. 3x plus 33. Now I can start solving like normal. So I'm going to add 2 to both sides. Get 10x equals 3x plus 35. X's need to be on their own side, so I need to boot 3x over to the other side. Kick them over. I'm going to get 10x's minus 3x's, 7x equals 35. Divide by my 7, so x is alone. And I get x equals 5. Make sure this one's also in your notes, so you can see one with a grouping symbol too. Now this one has a grouping symbol. You're going to want to make sure this one gets in there too. So we're going to take that 2, give it to the 2, 5, and to the 6. So I got 10x plus 12 on the left-hand side. Didn't change anything there. 2 times 5 is going to give me 10x. 2 times 6, 12. Now, I'm going to start solving. So I'm going to subtract 12 from both sides. So I'm going to get my numbers to the one side. So I get 10x, my 12's cancel, 10x. Oh, look, my 12's cancel again. Now, x is to one side. So I'm going to subtract 10x from both sides. So if I had 10x's, I'm going to take away 10x's. Looks like I got 0 over here. 10x minus 0. What is that about? What do you think? Now, there's a special term for when you get 0 equals 0, or if you would get 5 equals 5. There's a special term for that. What we call that is infinitely many solutions. That is when you get the same on both sides. You're going to want to make sure what I underlined here, the solutions when you get the same on both sides, make sure that gets in your notes. That's also called the identity. If you guys remember the identity property, that was 3 times 1 equals 3. So anything times 1 gave me that anything again. So if we got identity, the same thing on both sides, we know that we have infinitely many solutions. So on our last equation, we got 0 equals 0, which is true. 0 does in fact equal 0, right? So our answer would be infinitely many solutions. We would make sure that we write that as our answer. Now let's take a look at problem 5. Looks like nothing's going on over here that I need to change, but I notice I have some like terms on the right hand side. So I'm going to combine those. So I got -3m plus 12m. So I got 9m. And I have this plus 5 yet. So now I'm going to start solving. I'm going to add 4 to both sides. 9m equals 9m plus 9. Move my m's to the same side. I'm going to subtract 9m. Oh, look. Hey, that gives me 0. Okay, because they're going to cancel out. These guys cancel. Still left with that 9. So 0 equals 9. This one's even weirder than the last one, right? Because 0 doesn't equal 9. We know that. So what this is called is no solutions. So that's when you do not, emphasis on the do not, get the same on both sides. You're going to want to make sure that you get this one down also. So on our last problem, we got -4 equals 5. So our answer would be no solutions. I think we also got 0 equals 9. So 0, since 0 does not equal 9, we know we have to have a no solutions. So I'm going to do these two problems. You do not need to write them down unless you want more examples in your notes. So I'm going to distribute 3. I get 12b minus 6 equals negative 6 plus 12b. So I'm going to add 6 to both sides. Make sure I add 6 to the lone number. Get 12b. These guys are going to cancel. Looks like these two are going to also cancel. Left with 12b. I'm going to subtract 12b from both sides, and I get 0 equals 0. Now, if you remember back from a few slides, when we get a number that equals the same number, we can say that this is infinitely many solutions. And the final problem that we're going to look at today. So I'm going to distribute that negative 1 inside. So remember, we're always going to multiply. So on the left-hand side, it's going to stay the same. And I'm going to multiply that negative 1. So negative 1 times a positive 3 is going to give me negative 3. And negative 1 times a negative 2 is going to give me a positive 2x. Because remember, a negative times a negative will always give you a positive. So I'm going to add 3 to both sides. I could have subtracted 7, but I'd rather add 3. So I'm going to be 2x plus 10 equals, those guys are going to cancel out. I'm going to be left with 2x. Now I got to get 2x away from this 10. 10 needs to be alone. So I'm going to subtract 2x. Cancels. I'll be left with 10. Ooh, those cancel too. 2x's minus 2x's does give me 0. So I get 10 equals 0. Now, when we get a number that does not equal the same different number, so 10 does not equal 0, right? I'm going to get a no solution problem. That's the end of the video. Thanks for watching.